Solving quadratic equations by extracting square roots. Quadratic equations that can be written in the form x squared equals k can be solved by applying the following properties. If k is greater than 0, then x squared equals k has two real solutions or roots. That is, positive or negative the square root of k. If k equals 0, then x squared equals k has one real solution or root. If k is less than 0, then x squared equals k has no real solution or root. The method of solving the quadratic equation x squared equals k is called extracting the square roots. Examples. Example number 1, determine the number of real roots of the following equations. Number 1, we have x squared equals 9. So the value of k is 9. Since 9 is greater than 0, therefore the number of real roots is 2. 4x squared equals negative 8. We are going to simplify first the equation by dividing both sides by positive 4. So 4x squared divided by 4 is x squared. Negative 8 divided by 4 is negative 2. Now, the value of k is negative 2. So, since negative 2 is less than 0, therefore, there is no real roots or there is no real solution. Next example. 2c squared plus 16 equals 16. Simplifying the equation, we can apply the addition property of equality. So it will give us 2c squared equals 16 minus 16. So 2c squared equals 0. Dividing both sides by 2, the result is c squared equals 0. Now, the value of k is 0. So, since k is 0, we only have one real root. So, in this lesson, it is very important to memorize the perfect square or at least familiarize. So, let's have a short review. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. And so on and so forth. Example number 2. Solve by extracting square roots. Given y squared minus 121 equals 0. So, let us transpose negative 121 to the right side of the equation. Y squared equals positive 121. So, applying the square root principle, if x squared equals a, then x is equal to positive or negative the square root of a. Applying the said principle, we now have the square root of y squared equals positive or negative the square root of 121. Simplifying, that is, y equals positive or negative the square root of 121. Simplify and get the square root of 121, that is 11. So, the answer is y is equal to positive or negative 11. Next example, solve by extracting square roots. 8m squared minus 29 equals 3. So, let us transpose negative 29 to the other side of the equation. We have 8m squared equals 3 plus 29. 8m squared equals 3 plus 29 is 32. Dividing both sides of the equation by 8, so we have m squared equals 4. Applying the square root principle, we have the square root of m squared equals positive or negative the square root of 4. M is equal to positive or negative the square root of 4. So therefore, M is equal to positive or negative the square root of 4 is 2. Third example, solved by extracting square roots. The quantity of x plus 1 raised to 2 equals 25. Applying the square root principle, we have the square root of the quantity of x plus 1 squared equals positive or negative 25. X plus 1 is equal to positive or negative the square root of 25. Bring down x plus 1 equals positive or negative the square root of 25 is 5. So, let's find for the value of x. So, x is equal to transposing positive 1 to the other side of the equation, that is negative 1 plus or minus 5. So, let us solve for x sub 1. X sub 1 equals negative 1 plus 5 is 4. X sub 2 is equal to negative 1 minus 5 equals negative 6. So, therefore, the roots of the equation, the quantity of x plus 1 squared equals 25 is 4 and negative 6.